Let us see about input and output characteristics of CB, CB and CE, CB and CC configuration. CB configuration. Here this is the circuit diagram of CB configuration. In common emitter configuration, here base is grounded and it is used as a common terminal for both the input and output. It is also called as ground base configuration, and here the emitter is used as an input terminal, whereas the collector is the output terminal. And next, here now we can see the input characteristics and output characteristics. While we are finding the input characteristics, it is defined as the characteristics curve drawn between the input voltage and the input current, whereas the output voltage is constant. And to determine the input characteristics, the collector current by collector base voltage VCB is kept constant at 0, and the emitter current IE is increased from 0 by increasing VEB, and this is repeated for higher values of VCB also. And here the curve is drawn between the emitter current and the emitter base voltage at constant current collector base voltage, and is given by diagram. In this, the VCB is 0, that is emitter base junction is forward bias, so it is behaves as a diode, so that the emitter current increases rapidly. And that's about the input characteristics. While we are seeing the output characteristics, it is defined as the characteristics curve drawn between the output voltage to the output current, whereas the input current is kept constant. And to determine the output characteristics, the emitter current IE is kept constant at 0, and the collector current IC is increased, therefore from 0 by increasing CBE, and this is repeated for higher fixed values of IE. From this characteristics, that is the constant value of IE and IC is depend on VBB, and the curves are parallel to the axis. Therefore, as the emitter is forward bias, that is the majority carriers, that is electrons from the emitter region, are injected into the base region. This is the output characteristics. Now you can see the transistor parameter in CB. First one is the input impedance. Here the input impedance is defined as the ratio of the change in input voltage to the change in input current, with the output voltage is kept constant, and this is given by HIB equal to del of VEB by del IE at VBE is constant. And the output admittance, it is defined as the ratio of the change in output current to change in output voltage with the input current is kept, and here this is given by this equation. And next one is the forward current gain. Here it is defined as the ratio of change in output current and to the change in input current, with the output voltage is kept constant. This is given by this equation H, and it is denoted as HFB. And next one is the reverse voltage gain. It is defined as the ratio of change in input voltage to the change in output voltage, with the input current is kept constant. Therefore HRB equal to del VB by del VC at IE equal to constant. Next one is CE configuration. In the CE configuration, this is the diagram, and here the emitter is grounded, and it is known as the used as the common terminal for both the input and the output. It is also called as grounded emitter configuration. Base is used as an input terminal, whereas the collector is the output terminal. And now while we are seeing the input characteristics, it is a graph drawn between the input voltage to the input current, whereas the output voltage is kept constant. Here the curve is between the base current and the emitter voltage at constant collector base. This is the input output characteristics. Here the base width increases, so the curves most rise as VCB increases. Next one is the output characteristics. Here the curve is drawn between the output voltage and the output current, whereas the input constant current is kept constant. Here it is repeated for higher values of IB also. And while we are seeing the output characteristics, there are three regions, that is active region, cutoff region and saturation region. In the active region is defined as the biasing arrangement, the cutoff region where the collector current is 0, and the saturation region, the region of the characteristics to the left of the VBE is 0. Now we can see the parameters. Here the input impedance, we all know that already it is defined, that is HIE equal to del VBB by del IB into VBE, and this is the output impedance in the case of CE configuration, and this is the formula for the forward current gain, and this is for the reverse current. Now we can see the CC configuration. While we are seeing the CC configuration, Here the collector is grounded and it is used for as the common terminal for both the input and output, and it is also called as grounded collector configuration. Base is used as a input terminal, whereas the emitter is the output terminal. And here while we are seeing this input characteristics, that is the curve drawn between the input voltage to input current, whereas the output voltage is kept constant, and here the curve is drawn between the base current and the base emitter voltage at constant collector current voltage is shown by using this diagram. And this is the output characteristics. It is defined as the characteristics curve drawn between the output voltage to output current, whereas the input voltage current is constant. To determine the output characteristics, the base current IB is kept constant at 0 and the emitter current IB is increased from 0 by increasing VBE. This is the transfer parameters, the input impedance of the common emitter configuration, and the output. This is the output admittance of the common emitter. Next one is the forward current gain of the common emitter configuration, and the last one is the reverse current gain of the common emitter configuration. That's about the input output BCC and CE configuration. Thank you.